In this video, I am going to explain the differences between SN2, SN1, E1, and 2 reactions. But there are a lot of factors and characteristics that go in between them. So instead of explaining the whole thing by detail from scratch, I'm going to go through these practice problems to hopefully make the differences between them and similarities between them make more sense. So for the first one here, we see that we have this molecule here with a good leaving group, bromine. So all of these reactions, SN2, SN1, E1, E2, they require a good leaving group, like either bromine, chlorine, OMS, OTS, anything that can leave with a stable negative charge, right? And our nucleophile or base strength here is going to be NaCN, where specifically we are worried about the CN minus. This CN minus here is specifically a weak base, strong nucleophile, which is a big indicator of SN2 reactions, right? So for SN2 reactions, we are going to do one step where we are going to attack less substituted substrates like this to kick out the leaving group and do an inversion of stereochemistry. So when we substitute that bromine with the CN, we are going to invert that wedge into a dash CN, right? And the Br minus just leaves as a leaving group. So that's the SN2 product. Moving on to the next one, we see that we have a secondary substrate with a good leaving group, chlorine. So then we have to determine what the nucleophile or base strength of this ethanol is. It is a weak base, weak nucleophile. So this is a big indicator for SN1 and E1 reactions, right? The very first step of SN1 and E1 reactions is to kick out the leaving group to form the carbocation intermediate. Once we have formed that carbocation intermediate, we then have to look out for any carbocation rearrangements like a hydride shift or methyl shift. In this case, we could do a hydride shift to convert that secondary carbocation to the more stable tertiary carbocation, right? Because of hyperconjugation. Then from here, we could either make the SN1 product, which is the major product, or the E1 product, which is the minor product, unless you have heat, right, which is a delta symbol or a triangle symbol. So let's focus on the SN1 product first. Let's bring in an ethanol, attack that carbocation, and get this intermediate right here. Where the oxygen of that ethanol is the nucleophile, attacking that carbocation, which makes this the new bond right here between this oxygen nucleophile and this carbon electrophile. Right? This oxygen is still attached to its ethyl group and hydrogen, which is why it has a positive charge right there. Then we are going to deprotonate it with, let's say, another ethanol, or you could even use the leaving group that left to neutralize that positively charged oxygen to get your SN1 product here. Right? So now that's the SN1 product, but let's say that we want to make the E1 product. To make the E1 product, we want to make the most stable